Hello and welcome to an algebra tutorial video working our way through single variable inequalities. In this video we're going to talk about set notation. So set notation in a way is not directly related to inequalities, but a lot of times you first are taught it or you first kind of pops up in your algebra class or whatnot as you're starting to get inequalities. So all set notation is just a way to write solutions algebraically. It's just kind of it's a fancy way, it's a different way, and this may be new for a lot of you guys. But let's go back and think about what inequalities are. So I've got 4 different inequalities here. Let's think a little bit about this first one. A number is greater than 10. There's my inequalities. I have something greater than. If I just want to translate this into an inequality, I might say, okay, I have a number n, and it's greater than, so it's opening up towards n and pointing to what is smaller. So it's pointing to 10 because 10 is smaller than n and n is greater than 10. So there's one way to write my inequality. Set notation is more of a formal way. It uses some more symbols. So I'm going to write the same inequality in set notation. So set notation, you would put a little kind of squiggly line like this, indicating I have a solution. I have solutions here. I should actually backtrack one more time before we even go to set solution. Let's think about, well, if I have a number greater than 10, what are all the possible solutions? Well, all the numbers greater than 10 are 11, 12, 13, 18, 55, 1 million. There's a lot of solutions, right? And in fact, there are an infinite amount of solutions. So we've done equations, solving equations, we always get to a point and we find what is x equal. Boom, we got our number, that's my solution, I'm happy. In this case, as we're dealing with inequalities, lots of times we have an infinite amount of solutions. So how do we go about representing all the possible solutions? That's where set notation comes into play. So set notation is a way to show multiple solutions to some sort of algebra context or situation. So here we go. We have a number greater than 10. We know there's a lot of solutions. We intuitively know there's an infinite amount. I can't list them all. So if I want to write it in set notation, all the solutions, I would do a squiggly line. There's my set notation. That means I'm going to tell you some solutions for the variable n, so that's my variable involved. This little line is kind of separating. It said, okay, I'm telling you the solutions for n. This line is separating it. Now here's what the solutions are. The solutions are that anything such that n is greater than 10. And I close off my symbols. And there's representing the same inequality in set notation. Now you may say, well, it's the same inequality. N is greater than 10, n is greater than 10. So why do I need all these extra symbols? Well, set notation again applies to other situations. There's context algebraically where you'll get into eventually where you may have 2 solutions. You may have 3 solutions. You may have a bunch of solutions. You may deal with sets, groups of numbers. I want this group combined with this group. So set notation is used for far more than just inequalities, but we can use it to represent all the solutions of inequalities as well. So there you go. There's n greater than 10. So let's go through these other ones now. So number 2 is a number less than 10. So that would be n is less than. So I'm going to point towards n because it's less than. I'm going to open towards 10 because 10 is greater than n. N is less than 10. So some of the solutions to that then well, what numbers are less than 10? Well, that's 9, 7, -5, 0. Those are all possible solutions or numbers that are less than 10. So there's an infinite amount of those, so let's write that in set notation. So all the solutions then are all the numbers for n such that n is less than 10. And close off my little bracket there. Okay, let's get through these other 2 here real quick. A number greater than or equal to 10. Well, there's a number greater than or equal to 10 Now, this is really similar to number 1. The only difference is that my solutions are anything greater than, so 11, 12, and on, but it could also include 10. The number 10 is now a solution, whereas a number 1 up here, 10 is not a solution. 10 is not greater than 10. But if it's equal to, then 10 does count. So in set notation now, all the numbers n such that n is greater than or equal to, that's why I include that 10 there, to 10. And now finally for the last one. For a number less than or equal to 10, n is less than or equal to 10. So the solutions in this case, for number 4, the solutions are 10 as well in this one. So 10 is less than or equal to 10, but so is 9, so is 8, so is 7, going down forth. And in set notation, all the numbers for n such that they satisfy n being less than or equal to 10. Okay, so kind of a no-brainer, not too much of a stretch to connect the words that we're seeing into the right inequality, thinking about solutions that work and solutions that don't, trying again distinguishing between greater than and less than, or greater than or equal to and less than or equal to. And now we have this set notation way of writing inequalities and all the possible solutions, because when we're dealing with inequalities, there are an infinite amount of solutions that we need to think about, represent, and work with.